Okay, good morning, students. How you doing?
Good morning.
Good morning.
Yeah, good morning. Okay, so tomorrow is that midterm on everything that we looked at so far. There's a review up there. Uh, and that's what we can concentrate today on if you'd like, or any other questions. I'll be glad to handle. And just because the exam is a super grade, it's 25% of the whole grade. All of my tests put together, all 5 tests, or match up with the same percentage as the midterm. So this is a major grade. So what I tried to do is I tried to make some adjustments. I think there's a 3-day uh, kind of grace period on the homework things, the individual assignments, and then so to give you some flexibility, and then you got a little bit more flexibility since it's on the exam is on honor lot. You're supposed to be able to do it within that time period. So I gave you a couple of extra days. I gave you some grace during the day, and then after Thursday, you can still take it. And I think it sets a penalty, just a one-time penalty of 10%. Like I said, I'm trying to make this so you do have some leeway, but we got to realize that the midterm grade that comes out next week is based upon all the grades so far. So that's why I want to have that midterm in there. And that's really what it's designed to have that in there. All right. Let's see what we can get into. Anybody got any specific questions? Oh, this is the wrong class. No wonder it's not. Got to go over to the 120 to get that review. Go into student view. Where in the world is the midterm review at? Gotta make sure it's there. Do I have? Oh, it's right there at the top. Hmm. All right. Is the set of all integers between 11 and 22 equivalent to the set of all integers between 33 and 44? Well, I'm going to take the safe way and just write out which in each of those sets. Okay. All right. So the first set would be, it says exclusively, so it's going to start at 12, 13, 14, 15, 16, 17, 18, 19, 21. Exclusively means that that it does not include the endpoints. Sort of like if there's no less than or equal to or greater than or equal to. If it's just the inequality, then it includes the values on the end. So then another one, we'll do the second one. So it's exclusively, so it's going to start at 34, 35, 36, 37, 41, 42, 43. Okay, so how many is that? So this one's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is the answer to this?
Yes.
Yes. They're equivalent because they have the same number of elements. It's not equality, it's equivalence. Equivalence means the same number of elements. So two sets are equal of what? If they have different cardinal numbers, only number elements, only non-numeric elements, or all of the same elements. We can rule out different cardinal numbers because if they're not equivalent, then they're not equal. It doesn't matter what elements are in the sets you're comparing. If they're equal, they could be numbers, they could be letters, they could be vegetables. It does not matter when it comes to the type. So both of these we can rule out. And so they have to have all of the same elements. Okay? Let's see what else we got. So we just need to find out how many is in this set. So write it out in roster form. So we're looking for one that's divisible by 6. It's a counting number, n, natural number, and it's between 30 and 56 non-inclusive. So then it's 31, 32, 33, 34. We're going to be doing it a while because it goes up to 50. Oh, wait a minute. It's divisible by 6. All right. So 30 is divisible by 6. So 36 is the first one that's divisible by 6. 42 is 6 times 7. So that one as well. 48. And then 54. And I do believe that's it. So the cardinal number is what? The cardinal number is
4.
4. Exactly, 4. It's the number of elements in the set as the cardinal number. So the number of elements in C is equal to 4. And that's what I put down there. Use the image below to determine the elements of A. All right. Let me get rid of that, and then I'm going to put the full thing on there. So here's the Venn diagram. So the Venn diagram shows what's in A, and everything outside of A is not A. So what are the list of elements that are not in A?
0, the only one that's not in A. So it's 1, 2, and 3 that's in A.
Okay, but let me back up a second. You're right, but you zigged when you should have zagged. Let me go right back and show you what I'm talking about. Because it's asking what's in A. I mean, sorry, not A. Okay. So A has 1, 2, and 3 in it. The only one of the elements that's not in A is the one that's outside of A. And that's the 0. Okay, see, it wants not A. So it's just this one right here. And that's a 0. Okay. Any questions about that? So watch that. It's not talking about A. It's A complement. The little exclamation, what do you call that? Accent mark, or sometimes they'll use a C. All right. So 0, the only element not in A. How many proper subsets? So we got N, N of X is equal to 2. Okay, there's our N. There's 2 elements. So then we're using the formula two to the n. And proper subsets means we're going to throw one of them away because we want to throw out the one that has a quality. That's what makes it a proper subset. All right. So 2 to the nth power minus 1 is equal to 4 minus 1, which is 3. Okay. Any questions about that? If it had not said proper subsets, then it would be 4. Proper subsets means we got to subtract 1 from the 2 to the N. All right, so here we got two sets. The universal set, 1 through 10 natural numbers. A is the even ones, 2, 4, 6, 8, and 10. B is 1, 3, 5, 7, and 9, the odd ones. Okay. So are these sets overlapping, disjoint? Is A and B complements? If we're not
So I
sure, we
got-
can draw something.
So I got
It's
A
what?
and U are this sets, and B is the complement of A. And I got
Okay.
A
Yeah.
and B are disjoint sets. So the
So
only
they're
one I
mentioning
didn't.
is that one, right?
Mhm.
Now, what about the third one? Now, these right here, they're talking about A and U. They're talking about these.
Mhm.
Okay. These are obviously not disjoint because A has the even ones as well as U does. So they're not overlapping. And I'm sorry, they're not disjoint, but they are overlapping. But let me ask you about the third one. Is B the complement of A? This is how we can find out. Let's write them down, the 10 in the universe. And then we're going to come over here and see if it's a complement. So we're going to take 1, 3, 5, 7, and 9 out. And what's left is 2, 4, 6, 8, and 10. So therefore, these, they don't have any intersection. And just by being disjoint, they're also complements. Okay? But A and U are not disjoint because they've got common elements. And A and B also are disjoint. If you put the A and B together, you get U again. All right? So here's we got this Venn diagram. A's got some funny symbols at 2.5, B, 4, and F. B has got A, 3, 1/3, and then they both share 1/2 C and 4.14. So what's the question here? Find the intersection. So the intersection
It's the
is
one
the
half
little
the
football.
C and the 4.1.
Exactly. Exactly. Right here. There's your intersection. So 1/2 C and 4.1. Good. And it's the first one there. All right, some little set operations here. Let A be the set of letters in the word information and B the set of letters in the word possibility. Okay. Which of the following represents the union? Well, we just got to put all of them together with no repeats. Let's see if I can do it and then match it up. All right. So, what's the first letter in the alphabet? I'm going to try to do them in order. Oh, they don't have them in order, so. Okay. So we just got to get all of them. I, N, F, O, R, M, A, T. I don't need another I. And I don't need another O or N, right? Because I've already got those. On the possibility side, I got a P. I already got an O. So I don't need another O. I don't have any S's, so I'll put an S in there. We already got an I, but we need a B. We don't need another I. We need an L. We don't need a T. We already got a T and an I. So that should be it right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, is that right? They got them in different orders, so we got to.
So it's the last one.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And that looks to be it. Good work. Good work. All right. So if we've got a set A that's got 12 elements in it, and we got a set B that's got 15 elements in it, then how many are in the intersection? I'm sorry, they're given that the number of elements in the intersection is 0, then how many are in the union? Well, this is a formula. The number in A plus the number in B minus the number in A. All right. So the number in A is 12. They give it to us right there. The number in B is 15. And then 0. So then this is 7, 27, 30. Yeah, 27. 5 and 2 is 7. 1 and 1 is 2. Okay. Make sense? All right. So we got 2 sets in a Venn diagram. Made up as such. So this is the intersection right here. So this is your intersection. Okay, they're asking about the intersection between what? They're asking for the intersection between A. Now, A is all of this. I'm going to see if I can color this and if it'll work like that. So here's A. Okay. Now I'm going to use a different color. Let's see if I use yellow, what'll happen. And then B complement is this part. And it also includes everything outside, but there is no outside. It's just the 2 circles. So therefore, the part that's the intersection, in other words, where I have both the orange and the yellow covered, is the intersection of these 2. Because that's A right there. And B complement is what's not in A. So the only place they intersect is A. So 0, 2, 8, 12. Okay. Makes sense? See anything that looks weird? Did I do something silly? Okay.
Wait, I thought it was everything besides what's in the intersection.
It's the intersection of B complement. So B complement
Oh, it doesn't
is,
have
is
the
this part.
parentheses.
Yeah,
Okay.
it doesn't have the out. It doesn't have anything on the outside. So
Yeah. Okay.
if they had a square and there was anything in that, then yeah, it would be included. But this is the only intersection of A and B complement. Okay. If it asked for B complement, then it would be everything on the outside. And A is only the circle. So the
Yeah.
only the place that they meet is the yellow part.
Okay.
Because that's B complement. And that's also A. So that's the intersection of those two. Because there is part out here. There's nothing in it. And it probably would be clearer if they did have something out there. But it would still be just the A only that it would be the intersection. All right. Oh, this is a crazy one. I took this one out of the test. So it's a little bit long. But we got 2 periods to do this. All right. So you work on the inside out. So A intersection C is looks like it's a TA. So A and C have in common. They don't have F. They have T in common. They don't have Y. They don't have K. But they do have A in common, right? So now I'm going to take that and intersect it with B. Okay. So I'm going to take that and intersect it with B. And what do I get? All right. So C has got T and A. And then I'm doing the intersection between that and B. It looks like the only thing they got in common is T, right? So the intersection between AC, which was TA, and B, or just the T, because there's no A down here. All right, and then we got to find C intersection B, which is going to be
E and D
D,
and E.
E. So there's no F on C, there's no R on C, and there's a T, right? Because they both have a D, they both have an E, and they both have a T. Now, the final step is to union this with that one. So that's just going to be a matter of putting the two together, and it's just going to be D, E, and T. It's union, not intersection now. Okay? All right, a survey of 360 people found that 250 only drink coffee, 80 drink only tea, and 30 drank both. All right. So probably the best way to go about this is just to create one real quick. All right, so then inside. All right, so I'm gonna go ahead and just fill it out with what I know. So 30 drank both. Uh, 250 drank. So this is C. We'll see that's coffee, and this is tea. So then 250 only drank coffee, and then 30 drank both, and 80 drank only tea. And then we're gonna have a number out here. So 250 plus 30 plus, so 360. So there's none out here. It's 0 out there. Okay. So let's see if we can find that one. Not that one. That looks to be it. Let's just double check. So it's this one. Okay. So I just filled out the Venn diagram from the description and then matched it up. All right, so we just need to know which one of these are statements. Remember, a statement essentially makes a factual claim. So I will go for a walk later today. Every prime number has. We could leave out the papaya as my favorite fruit. And we can also leave out this. If it said this, or it said any number, then yes, it would be a statement, but it's an incomplete statement. It's like if we took the second one there and it says, I will go for a, and didn't tell you what it was you're going to do. Determine which of the following statement is a compound statement. Oh, okay. So all of these are compound state. Oh, wait a minute. So I guess we're talking about this one. Three is less than or equal to 17. Yeah, I mean, that's not a compound statement. You know, if you had another one and you had and, or, you know, the conjunction symbol or the or symbol or one of the other ones in there, but this is not a compound statement. All right, we'll write the statement. Everybody that eats fries, drink soda in symbolic form. P is the statement, they don't eat fries, and Q is they drink soda. Now we got to watch out because they're purposely writing the statement as in the negative. So P is they don't eat fries. So everybody that eats fries. So not P. So if they eat fries, then they drink soda. And so that one would be, which one? Looks to be that one, right? Wait a second. Do I have it backwards? Everybody eats fries. So if not P, then they drink soda. So that's right. What was that? Did you see something?
I was just saying I got the same answer as you.
All right, good.
So, yeah.
All right, so let P be the statement, there are 4 seasons, and let Q be the statement, it was composed by Vivaldi. All right. There are 4 seasons is P, and Q is Vivaldi. All right. So which one is represented by this?
The
P and
last
Q.
one.
So he just,
The last one.
there are 4 seasons, and it was composed by Vivaldi. Exactly right. That's the only one that's and. There's no or. All right. So let P be statements whose truth values are unknown and could each vary. Determine the possible combinations of truth values that P and T could take on, as well as the truth values of the negation of the statement. Use this information to fill in the blanks. Okay. All right. So basically, this is just asking us for our standard stuff. All right. As I had showed you about setting it up when you got two statements, you got 2 columns, true, true, false, false. And then the Q would be true, true. I'm sorry, true, false, true, false. So when you got 2 statements and 4 rows, then these are going to be exactly like that. So the not P is just the opposite of P. So if it's false over here, you can see the pattern here. True becomes false, true becomes false, false becomes true. And so this false will also become true. And then the not Q is just the opposite of Q. So it's true here, so false over there. All right. So it's just basically asking for standard practices of the basic operations on truth tables. All right. Given that P is false and Q is false and R is true, find the value. All right. So the way I like to handle this is just rather than doing a truth table, I can just do the one instance that they're asking about. So this is false. And Q is also false. All right. So the negation of false is true. True or false is true. So the whole statement would be true, that one. Let's do this one. So again, it's not P, so it's not false, which is going to change it to a true. And Q is also false. And then this is true. All right, so this is going to be true or false. So I'm just doing these as we go down. True or false is true by the OR rule. And if true, then true is also true. So both of them are true. It looks like it's the first one, right? Because it'd be true, false, 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 true, and true, true. Anybody dissenting on that? I think I did it right, but
I got that one as well.
okay, good. And incidentally, you could also do a truth table for the whole thing, which is going to have 8 rows, and then go to find the one that says FFT in that order. In other words, P false, Q false, and R true. There'll be 1 row in there, and then you can look at the end, the final column, and see what the truth value is. But we did the same thing here by just looking at that one instance. All right. All right. I guess we're going to have to actually do a truth table here. And it's a big one. I did take out, there were 3, I think, long ones in here. I took out all but like 2 of the truth tables. But again, it still is an integral part of the lesson, the truth tables, because it's about 75% of everything is the truth tables. The other 25% is equality and negations, which you can also tell with truth tables. But also, too, you can sometimes tell that an argument is not valid by looking at the argument structure. All right, so let's see what we got here. Below, which of the tables is the truth table for the statement? Okay, it's got, let's see. So I'm just going to have to go ahead and prepare for the big. So there's 3 statements, P, Q, and R. So there's going to be 8 rows. The first one, all right, so 4 truths. It helps if you got ruled paper. And then 2 truths, 2 falses all the way down. For the middle one, true, true. So true, true, false, false all the way down. And then the last one, no matter how many rows it's got, it's always true, false. Just repeating. Okay, and see how each one of those is different? for example, remember we were looking for false, false, true, true. So on the truth table for that last one, that would be essentially the last row of the truth table would be your answer for that. All right. So thankfully this is not too bad. P or Q. So we're just using the standard or. In other words, or is only false when we got two falses. So this one, we're looking at the first two columns, so true. And there's our falses. All right. So that's that one. And then the other one we need is not so bad. It's just a negation. So it's a negation of the last column, which is going to be false, true all the way down. Opposite of true is false. The opposite of false is true. So false, true, false, true, false, true, false, true. And then the last is just put them both together with an or. I'm going to put the whole thing in here, but like I said, we're really looking at the or. That's what we're doing. We've already gotten the this part done, and we've got the not or done. So we put these two together with the or. The or is always true unless we got two falses. Let's say true, 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 true. So true, 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 true. So, and then false, false, and then over here, false, true, false, true, false, true, false, true. And so it's everything but but the second to last one is an F. Looks like it's this. No, it's not that one. It's got to have all T's. And not that one, but it's this one right here, the last one. See that? 1, 2, 3, 4, 5, 6 T's, one false, one more T. All right, any questions? I'm just going to keep rolling unless y'all got a question. All right. Consider a statement. I like to drink coffee, or I like to drink coffee and milk. And this is that, I think this is that same one. We can do it. But we're going to use De Morgan's law. I think what it is, I think I had mentioned last week when we were studying for chapter 2 that they were missing parentheses. I don't think that's what they're doing. I think what they're essentially, they have a standard So in other words, I think what they're doing is they're putting the comma after the or, but let's see what we can do. All right. So what this is, let me write it out because we want to have an equivalent statement. So I'm going to try and use De Morgan's law here to just make it a little bit easier, because otherwise I'm doing the truth table for 4 of 5 different ones. So sometimes these little rules we pick up can be used to save time. So this is okay. So that one is of the form P or P and Q, because I like to drink coffee, or I like to drink coffee and milk. Okay. So essentially black coffee versus cafe au lait. All right. So let's try to use I'm gonna have to think about this one, come back to it, because I thought De Morgan's law would help us, but
I just did a truth table and then had to do each one.
yeah, I guess that's the only way to do it. I thought maybe I could do it with De Morgan's law, but I don't see a way to do it with De Morgan's law, because De Morgan law can save you a lot of trouble, especially with the negation. And if you have one that's already in the negated form, in other words, like it is not the case of A and B, or if it's the intersection of the complements kind of thing, then you can figure out what it's going to be. But we don't have either one of those here. So yeah, let's just go ahead and do the truth table. All right. So it's just the truth tables take a long time to write them out and everything, you know. Thankfully, this one's only got 2
I wish it was
statements.
short.
Well, this one's not too bad. I mean, even that one that had 8, it was a short one once you had to do it. But I did try to take that in consideration to take some of those out. All right, so P. So true, true, false, false, and then true, false. All right, so then this one would be we need to have the P and the Q. So it's just basically true, true, false, false. It's the standard one. And then here, we're going to do both. All right, it'd be P or P and Q. So now we're just putting these together with or, the first and the last column. True, true, false. Oop, false. So we're looking at this one and the first one. So true and true is true or true is true. True or false is true, but false or false is false. Then we got 2 of those. All right, so let's try to do the other ones real quick. All right. So this one would be P and I just don't like this question. That's one reason why I took it out. I was going to take it out because
None
it's
of these
just, I just don't like it. There are other ones that are better to do this kind of thing, to find equivalent. All right. So this one is P or Q. So we only got 3 of them. So it's P and P or Q. All right. So we got to have a P or Q. So P or Q is just going to be true, 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 and false, the standard one. And then we're putting it together with a P. So this would be P and P or Q. All right. So we're using and to put together this one and P. So it's and. So we got to have 2 truths or else it's false. And you know what? We hit it right off the bat. Is that right? I'm not going to do the rest of them. So this one
I didn't
can
do,
be done.
I might have did it wrong.
I got
All
I
right.
got answer number 2 as mine. What'd you get, Brandy?
Well, actually, I did none of the above just because what I had, I think I may
Me
have done it
too.
wrong.
I get up above.
I got true, false, false, false for the second.
Yeah, so for the second one, I got true, false,
Okay,
false,
so this
false.
is an equivalent one right here. So the conditional, just the basic conditional, P, Q is equivalent to not P or Q, okay?
Wait, hang on, a whole different question. I'm so sorry.
What's that?
I
Yeah,
just
he do
realized
for
we're at a different question now. I'm still on the other one.
Oh,
I
okay.
got distracted. I
Well-
apologize.
Oh, that's all right. Let me know if you need help with that one. All right. So this is an equivalence that we've got for the conditional statement. It's equivalent to not P or Q. So if our statement looks like this, the conditional statement, then we can write it as not P or Q or R. Because this right here is sort of like the Q. It's just 2 things now. So now, do we have any of those? I don't see it. I tell you what, let's come back to that one. I want to see how many I can finish up because I think I need to do something on that one. Consider the junction. Either you don't like the library or you like to read into a logically equivalent conditional statement. All right. This is where we should be able to use that same thing that I just mentioned up there. So this is the not P or Q. So Either you don't like to read or you read. So this is the one, and it's in that form already because the P don't like the library is already negated. So we should be able to just find one that looks like this. If we like the library, then we like to read. And it's the last one. So this is that other equivalence that's kind of like came along where the one we've talked about De Morgan's law in this chapter, in the chapter 2. And so it's the last one. So those are equivalent statements. Either you don't like to read, either you don't like the library or you like to read. So the equivalent is if you like the library, then you like to read. All right. So this one was asking for the what argument it was. So what I'm going to do is I'll just write over here. If you make dinner, so that would be P. Then you have dirty dishes. If you have dirty dishes, then you will clean them, which is like an R, right?
Look at what you watch. You can look at my face every time I put something in the cabinet.
Okay, so then here, if you make dinner, then you will clean dishes. All right, so that's the argument form. That's the symbolic argument form. That's the law of syllogism. Let's see, make sure that that's the right one. I can look in the notes, but I thought maybe they might have it written out here, which they don't. Let's go over to the notes. Yeah, the law of syllogism. It's a valid argument. The caterpillar is inside a cocoon. Is it valid to conclude the caterpillar is a butterfly? Let's see if we can write that argument out. All right. So P okay. So there we got it. So let's kind of write this out. The caterpillar is inside a cocoon. All right. P I mean, that's not a valid argument. There's not enough. I mean, you got one premise, so you're going to have at least two premises, and then only then if it follows, like if it follows in one of these forms. So not valid. All right. So which of the following can be used? Can be answered by using a permutation. So we're looking for order. You're planning a road trip and there are 15 different cities you would like to visit. Due to time constraints, you can only visit 4 of the cities. If you do not want to repeat any of the cities, how many different ways can you visit the 4 cities you're interested in? That looks like a good one so far. Let's read the next one. If 10 friends are going to occupy 10 seats and a shuttle on the way to the airport, how many different ways can they arrange themselves in the shuttle? No, because there's no order. They don't talk about order. I mean, a topping on a pizza, there's no order. So there are 3 different mathematics courses, 2 different history courses, and 6 different language courses. If a student must take each one of them, how many different ways can this be done? So this is the only one that's a permutation, and that's because, you know, you're going to schedule them in a certain order because it says how many different ways can you visit 4 of the cities that we're interested in. So in other words, it's P. So that would be the one there. All the rest of those are either just like counting method or their combinations. So some cards, games start with each player being dealt 3 cards called the player's hand. Remember, there are 52 distinct cards in a deck. How many different ways without repetition, meaning no 2 hands are the same? All right. So we, at the end of the day yesterday, I showed you that little video about, the difference between combinations and permutations. And a hand in a card game is not dependent upon order. Let's say you got 3 aces. It doesn't matter what the order are. The 3 aces is what determines whether that hand beats something else. If you've got a 3, 4, and a 5, the order doesn't matter. Okay. So what we're going to do here is combination 52, and we're picking 3. So still got this open. So 2200 and 2200 and 100. 22,100. There we go. So this is just 5 factorial. It's talking about ordering. So it's just that factorial. You're not picking, you're picking them out one at a time and then order them on a shelf. It's sort of like the books. So 120. All right. So an 8-sided die has one of the numbers 1, 2, 3, 4, 5, 6, 7, 8 on its face. The die is rolled. Which of the following cannot be a probability of rolling a 5? Which of the following cannot? All right. The ones we want to rule out right away are ones that are not valid. We can write a probability as a percent. So 1 translates as 100%. 0 is 0. 5 is not a probability because it's greater than 1. A probability cannot be greater than 1 or 100%. a probability can also not be negative. It can be a fraction, but not negative. This one is written as a decimal, and that's fine. All right. So the question consists of 10 multiple choice, 3 essays, and 9 free response. If the questions are ordered randomly, what is the probability that the first question is a free response? Okay. So just probability. So there are 10 plus 3 plus 9. So let's see, 19, 20, 21, 22. So there's 22 problems. So the first problem would be of it being a free response, 9/22. Because the total is 22, and 9 of them are free responses. So the first time we pick one, 9/22. And that's not something we can simplify because there's no common factor between 9 and 22. All right, so this is just, we're going to take 0.95 and multiply it times 32. So I don't know how many classes we have. We have like 10 a week, 10 classes a week. So over 7 weeks. So anyway, the point is, if somebody is on time 95% of the time, and there's 32 classes, how many classes would they be on time for? Well, 32 times 0.95. So it'd be 30 classes. So all you're doing is just estimating by that probability how many. All right, so we're just about time to write. So I will see you in a bit. If you got any questions, stick around here, all right?
Hi, Professor Cruz.
Hey.
I think it was number 21. Did you figure out how to do that one?
Yeah, I'll do it when we
Later.
come back.
Okay. All right. Thanks. My brain need a break.
All right.
See you later.
Bye-bye.
Bye-bye.